Okay, this is still graphing inequalities, but now we're going to graph 3 of them, and you have to find corner points again. So one thing that I didn't talk about in the last video is bounded or unbounded. Bounded means that it is encompassed by lines or the x and y axis. Unbounded means it has it's only got lines on one side of the region and it keeps on going forever. So we'll talk about that on this one. Okay, so I have 3 inequalities, and then I have my x is greater than or equal to 0 and y is greater than or equal to 0. So again, we're only working in that first quadrant. So I have x plus y is less than or equal to 11. That's in pink. I have x plus 5y is greater than or equal to 15. That's my green. And then 2x plus y is greater than or equal to 12. That's my blue. So first things first, you always find your x and y intercepts. So for the pink one, that's easy. The x-intercept is 11. The y-intercept is also 11. Okay, so I'm going to come over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's my x-intercept. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's my y-intercept, x-intercept, y-intercept. Here is my line. It is less than or equal to, less than and equal to. So I know I'm going to do a solid line. And now I have to use my test point. So the test point, again, is 0, 0. Zeros go in here. So I have 0 is less than or equal to 11. That is a true statement. So I'm going to shade where the 0, 0 is. So I'm going to shade below the line. Okay, so now the pink one's done. Now I'm going to do the green. So the green, the x-intercept, when y is 0, so x is going to equal 15. The y-intercept is when x is 0, so y is going to equal 3. So now I'm going to plot. So 15 is out here. X-intercept, the y-intercept is 0, 3. Here's my green line. Okay, and then the test point, 0 is greater than or equal to 15. This is a false statement. So that means I am not going to shade down here where my 0, 0 is. I'm going to shade above it. So I'm going to come up here and shade above it. Okay, so far, the feasible region, or where the 2 shadings intersect, is right here. Below the pink line, but above the green line. Okay? All right, last one. The x and y intercepts of my blue line. So the x-intercept, I cover up my y, and I get x equals 6. The y-intercept, I cover up my x, and I get 0, 12. Okay, so my x-intercept is 6. 1, 2, 3, 4, 5, 6. My y-intercept is 0, 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12. So here is my blue line. Okay, now I'm going to do my test point. So my test point is 0, 0. So 0 is greater than or equal to 12. This is a false statement. So I'm going to shade away from the 0, 0. So 0, 0 is here. I'm not going to shade below the line. I'm going to shade above it. So it's everything up here. Okay, so now you have to identify where are the 3 colors overlapping. Well, the 3 colors are overlapping right in here. So I'm going to draw on the outside of it. Here, here, and here in that triangle. So since all 3 sides of the feasible region are lines, that is a bounded, this is called a bounded region. All right, it's got bounds, it's got a boundary, right? It stops at a certain point. So what this means is all the points within this feasible region will satisfy all 3 of these inequalities. Okay, so what we're going to do now is now we have to find our corner points. Okay, so again, the corner points are where the lines are intersecting around the feasible region. So I have a corner point right here. This one is my pink and my blue line. This is why it's so important to have color coded lines, because then you know exactly which line you're talking about. The pink one, I'm going to erase some of this. Hopefully I'll remember. I'm going to write some of this over here just so I have it. It's going to be off screen, but you guys have it in front of you. So you should have it on your paper. And then green is 15, 0 and 0, 3. And then the blue is 6, 0 and 0, 12. Okay, because I'm going to need those. No, actually I won't. Because they are not, none of the corner points are an X or a Y intercept, so I actually won't need them. Okay, so here I have a corner point at the pink and the blue line. So I'm going to take my pink line, and remember, now the inequality doesn't matter anymore. And then I'm going to take my blue line. So the equation for the blue is 2x plus y equals 12. And I'm going to use elimination to solve this. So I'm going to go through and multiply everything through by a negative. So I end up with a negative x, negative y, negative 11. And now I can use elimination. The y's go away, and I end up with x equals 1. Now I can plug this back into the original. So if x is 1, 1 plus y equals 10. So my y is 10. So 1 plus y equals 11, excuse me. 1 plus y equals 11, and then I'm going to subtract 1, and I get y equals 10. So this point right here is at the point 1, 10. That's one of the corner points. Okay? The next corner point is right here, and that is my blue and my green line. So I'm going to take my blue and my green line and use elimination. And green is x plus 5y equals 15. So with this one, I'm trying to keep all the colors separate. With this one, I'm going to multiply through by a negative 2. I'm going to multiply this one through by a negative 2. You could have multiplied by a negative 5 and gotten rid of the y's. This is an x, excuse me. Okay, so when I multiply through by a negative 2, I get negative 2x minus 10y equals negative 30. And then I still have my original blue line. And now I'm going to use elimination. So that goes away. I end up with negative 9y equals negative 18. So y equals 2. I just divide by negative 9. Plug it back into the original. Either one, doesn't matter which one. So I'm going to plug it back into here. So I end up, I'm going to do it up here so you can see it. 2x plus 2 equals 12. And then I'm going to solve. So I have 2x equals 10. So my x equals 5. So this point right here, this corner point is x is 5 and y is 2. Okay, now if you look, my graph is pretty close. This is x is 5, go up, 2 is right here. This one, my other corner point, I go over 1 and up 10. It's off a little bit, but if you have the graph paper, which you guys will, then it actually works much better. It's a little more accurate. Okay, last corner point is the pink and the green. So the pink, I'm going to do it over here again. The pink is x plus y equals 11. The green is x plus 5y equals 11. And you notice the fact that I have different color lines really helps in identifying what the corner point is and which two equations I'm working with. So this one, I'm going to multiply everything through by a negative. So I have negative x, negative y, negative 11. Nope, this should be a 15. I'm getting ahead of myself. Okay, so I multiplied everything through by 11. Now I can cancel. So the x's cancel. I end up with 4y equals 4. So y equals 1. Now I'm going to plug it back into the original, either original. So I have x plus 1 equals 11, minus 1, so x equals 10. So with this one, my x is 10 and my y is 1. So those are the 3 corner points. So whenever you're graphing an inequality and you're doing a system of inequalities, you're going to graph like normal, you're going to shade like normal using that 0, 0 test point. And then where the lines cross around the feasible region, where they cross, you're going to use systems of equations. You're going to use elimination to find that point where the 2 lines cross. And that is that application of 5.2.